This is a video walkthrough for homework number 4. Before you start, let me be very straightforward with you. If you think that you have not achieved a good level of understanding on what we have learned during this week, I think you should spend more time either with a course recording or with this particular assignment, or both. Okay, I think it'll be just a plain suicide if you're trying to blindly copy and follow what I'm doing here without knowing what you're doing. Okay, so because this is just that important on the remainder of this course. Okay, so if you did not fully pay attention during the class this week, or if you were unable to make it to the class for some reason, or you only achieved some shallow understanding about the subjects we discussed this week, I think you should really go back and rewatch the course recording and come back for this assignment. Okay, I not only expect you to understand the technicality or the steps to complete this assignment, I also want you to understand what is the rationale behind why we do what we do. Okay, so it's that important. So let me start explain what this assignment is all about. So in this assignment, I provided you with a data set called a bottled water. So it's a measure of 5,000 Costco bottled water. So they're targeting with a filling level of 16.9 floor ounce. Okay, but if you look at the actual data, they're filling, they can't really fill exactly 16.9 floor ounce. Sometimes it's more, sometimes it's less. So we're more look like a range or a range of floor ounce instead of just single digit 16.90. Anyway, so start from there. Let's talk about first worksheet, which is bottled water. So in the first question, you're required to answer to find the actual mean and the standard deviation here. So for this, things will not be that difficult. All you need to do is basically using the mean and the standard deviation. Okay, mean and the standard deviation. So average and SD here. So we all know what is the function for the average. You just do B to B. Okay, B to B only works when you are summarizing a particular column. The column doesn't have anything but the numbers that you want. Okay, if there's anything else involved in the column B, you cannot use this way to get the average. That is the same with the standard deviation, ST, DV, S, B to B. Okay, so as you can see that they're pretty close. However, the standard deviation is 0.10. Okay, 0.10. So for next question, I'm asking you to construct a histogram using a weight column. Please use 20 bins to summarize. Please paste the histogram as a picture below. So for one purpose, which you're gonna see later, I'm gonna replicate this column. I think you should definitely do the same. I'm gonna using this weight replicated column to construct a histogram. So I'm gonna highlight C column, insert, okay, and then I'm gonna go to the histogram right here. You click OK. As you can see that our histogram is not quite centered. Okay, so there's a reason. I'm going to show you why this is so. So I'm gonna fix this X label, and you should also fix the X label. And I think I'm expecting you to generate exactly the same as mine. Okay, let's just put it that way. And then let's adjust this label, X-axis label, so that it's more readable. To me, it means just get rid of unnecessary precision. So number, it will automatically adjust to 2 decimal places. It looks good. However, excuse me, it is still not centered. The reason why this is not centered is because there could be some outlier here, extremely small value on the left-hand side of the data, which is not supposed to be there. It's just a really, really odd reason, and you got a very small data there for some reason you don't know, but that's kind of introducing huge bias here and introducing huge bias in the presentation of histogram. So for that reason, what I'm going to do is I'm going to just do a quick detection using another technique called box plot that tells me the existence of extremely small or large value and how many of those exist in this particular data set. So after highlight C column, I'm going to go to insert, and I'm going to do again here recommended chart, go to all charts, and then go to the box and whisker. Okay, you click OK. It gives you another way of representing the data. So as you can see that most of the data are concentrated between, let's say, 17.25 to 16.5. There's just one small odd value, okay, really extremely small value. It's here for some reason. I think that this is the reason why the histogram is not put on the center of the graph. Okay, so let's find out the smallest value. If you hover your mouse around here, it will show you the value, which is 15.94. I think you can see that. So let's find out 15.94, which is ridiculous. You don't need to keep the box plot, okay? Let's find out the smallest value here. So what I would do here, after highlight this, and I'm gonna go home, I'm gonna do here to sort it, okay? To sort it from smallest to largest. Make sure you're only highlighting the column C, not anything else, okay? Do it again. Continue with the current selection, okay? I'm not gonna expand the selection to sort everything else. Let's just sort column C. Column C is, remember, this is a temporary column. We can mess up with this, okay? This is only there in order to help us to construct a more reasonable looking histogram. And then as you can see that it's here, okay? You see that the difference here is huge as compared to the differences among other observations. So what I'm gonna do is I'm gonna simply delete this. It's not in the center. Okay, if you remember the second requirement I said, please use 20 bars to summarize this. So what I'm gonna do here is I'm gonna right click this area, which is your axis label. I'm gonna right click here again, and then you see the information here, number of bins. Currently it's using 38, but I'm gonna use 20. Okay, so there's enough details, okay, but not too many details. Okay, so this is a histogram I expect you to create. So this, I ask you to remove the title. I also ask you to remove the grid line. Just click here and it will highlight the grid line. Just click your keyboard delete key. It will help you get delete the grid lines. So this is nice, clean looking, and right click the whole chart and copy and bring it back to your Word file. Paste it as a picture. Okay, paste it as picture, the third option. Okay, so the advantage of pasting it as a picture is that if it's a picture, it's easier to adjust its size. Okay, make it just looking all right, and then move on to the next one. And then construct an upper or lower bound using one standard deviation. Okay, so construct a upper and lower bound using one standard deviation. Okay, so if you remember the empirical rule, I think you know where I'm heading. Okay, so what I'm going to do here is just going to create more space here. Okay, I'm going to say, okay, let me move on here. Upper bound, lower bound. So for the lower bound, it's going to be average minus standard deviation. For the upper bound, it's going to be average plus standard deviation. Okay, so you see we have upper and lower bound. So for here, what I'm going to do here is I'm going to create two flag variables. the first flag variable is going to determine whether that particular observation is too big. Second flag is going to tell whether this is too small. Okay, so too big. If it's too big, it's going to say 1. If it's too small, it is also going to say it's 1. Otherwise, it's going to be 0. So what I'm going to do here is, I think we need to use f function here. Okay, f, if this is bigger than the upper bound, then you say it's 1, otherwise 0. Okay, this statement is going to help you complete this logical test, whether b2 is larger than k6. If yes, then display 1. If not, 0. Okay, so for k6, we need to do absolute reference. Okay, if you don't know what that is, just do it. Okay, I pressed down my F4 key in my keyboard. I know some of the keyboards doesn't have that. If you don't have that, just need to type in the dollar symbol in front of K, another dollar symbol in front of 6. We do that. We also do that for this one. If whether this is smaller than the lower bound. Again, absolute reference. If yes, 1. If no, 0. Okay, so as you can see that this has been flagged as 1, meaning 16.65 is actually smaller than the lower bound. Okay, so highlight both of them and then double click the green dot at the end. Double click it, so you can see that a lot of observations here are either too big or too small because they're overflowed from the boundary that we have created. Okay, so I'm gonna create a third flag variable called outside. Okay, so as long as one of these are 1, and the sum is gonna be 1. Okay, because it cannot be too big or too small at the same time. So logically, if you're too big or you're too small, you know, the outcome of this outside variable is basically it's going to be a 1. Okay, so as you can see, a lot of them have been flagged as 1. So let's go back and see what the question is asking. What fraction of observations are within the bounds? Okay, within the bounds. So in this way of flagging, it's basically telling us what is a fraction outside of the bounds. Okay, so what I'm going to do is fraction outside of bounds. Okay, I'm going to sum f. Okay, because sum of f is going to tell you the number of observations that are outside of the bounds. Okay, you divide it by 5,000 because we have 5,000 observations there, and fraction inside of bounds. Okay, oops, I'm sorry. It's basically 1 minus this. So we have 68.94 which are inside of the bounds. So that concludes question number 3. Please recall the empirical rule. When compared, do you see substantial advantage of using? So it's basically asking you to compare whether there is a huge difference between the this answer here, 16.94, with empirical rule. So if you don't remember empirical rule, go flip the lecture note I posted, the stat lecture note I posted. There's a page I'm explaining the empirical rule. Just compare that estimation with this actual value that you have completed, taking so many different steps to see whether there is a substantial difference between that with this. Okay, and what is the probability of getting a bottle of water that is 16.80 or less? So if you remember, this is up until scenario, 16.4 ounce or less, right? It's up until. So you should use whichever formula I showed you. okay, since I'm so kind, okay, but I'll leave the rest to your good hand, in your good hand. 3, last one is always true. Okay, so you probably need average and standard deviation here. For that one, please use whatever you have obtained here in the step 1. Okay, so before I move on, some people may be wondering, why did you create this? Okay, why did you not use this column when you calculate the this flag variables? So again, this is temporary arrangement so that I can draw something more useful. Okay, the reason why I used original data is out of the respect of the original data. Okay, so that is why I did not use this to complete the rest of the question. Okay, so that is one logic. And if you move on to the next one, the sampling worksheet assumes that the weight of 5,000 bottled water are unknown. So let's move on to sampling. As you can see, we do have 5,000 here. We do have 5,000, right? However, this is kind of grayed out. Implies that you don't really know what's the value of each bottle there, okay? But you will eventually know through the sampling for some of those bottles, but not all of the bottles. Okay, so when the population mean and standard deviation is respectively, so it implies that these are something the question designer provided out of kindness. Okay, so that you don't struggle too much. So this is something provided. The population mean and the standard deviation is known as these two. Theoretically, what should be the mean and the standard error of the sampling distribution of the mean? So if you remember, Thursday class, we talk about the relationship between the population distribution with the sampling distribution of population mean. So in here, our sample size is, I think our sample size here is going to be 49, okay? 49. So with that information provided, I think you should be able to answer this, okay? And then follow the video, complete the random sampling process. You'll have all 10 samples filled. Your sample size is 49. What is the grand mean and standard deviation of all the means? Okay, let me show you how to do the random sampling first. Okay, here the idea here is you are drawing 10 group of random samples with each size of 49. With each size of 49, and then we can measure the average of all 49 observations from each sample. Okay, so it's simple. You go to data, and you go to data analysis, and you go to sampling here. You click OK, and input range is B. Okay, indicate that there is label in the first row, and you do random sampling of 49. 49. It's something provided, okay? And the output range is going to be here, H2. You click OK, and it will help you randomly select 49 observations out of that 5,000. It will present that to this particular column. Okay, so you need to repeat this for 10 times so that you have 10 different samples listed here. So I'm going to repeat one more time. Go to data, analysis, sampling, okay, B2B, yeah, and another 49. Only difference is the output range this time is going to be different. It's going to be I2. Okay, you click OK, boom. So we have another group of sample here. So you do that for all 10 of them. For each group of sample, you can calculate the average. Okay, for this one, you can just do it like this. Okay, and then you do that to all of them, all 10 of them. So when you have 10 samples presented above, you eventually have all this column, all these cells filled with the sample averages. The grand mean is basically average of all the averages you have obtained here already. Okay, and the standard error, okay, it's a standard error is standard deviation of all your sample means. That's basically what standard error is. Okay, so the standard error is basically telling you the level of spread on the sample averages. Okay, it's the level of spread of your sample averages. So remember, standard error are telling you something about the sample averages, not the individual units. Okay, again, I mean, that's a part of lecture. I'm not going to repeat that again here, but that is the point. So once you complete that, number 8 is asking you to compare the result you have obtained in 6. Remember, in 6, you have theoretical way of calculating the grand average and the standard error. Okay, and then number 7, you have this lengthy way of drawing sample and then finding out the grand average and the standard deviation of all the averages, which is also being called standard error. Okay, and then please find out the difference. Just find out the difference. So for example, if this is 1 and this is 2, the difference will be 1 minus 2 minus 1. Okay, just that simple. So do that, we can move on. And what is the chance of obtaining a sample mean of 17.05 or greater? So this is clearly beyond certain point scenario, beyond certain point scenario. So it says when the population mean stated in the problem 6 is true. Population mean, yeah, I should say population mean and the standard deviation stated in the problem 6. So basically you're using population mean and standard deviation of the population, and it's not explicitly mentioned here, but it's sample size, right? Because you need sample size to determine chance of obtaining sample mean of 17.05. It's not asking you to finding out the chance of obtaining a unit which is 17.05 or greater. It's asking the sample mean of 17.05. So it's asking about the sample mean, therefore you should rely on the sampling distribution instead of the population distribution. Okay, that's about it. This is a really rich set of questions that can help you evaluate every aspect of things we have learned during this week. Okay, if this is not enough, please shoot me an email or send me a message. We can talk more. Okay, thank you.